Hello everyone, welcome to Sources classes. So in this video again we have come up with a very interesting question from the quantitative aptitude section and particularly geometry. So this is a very interesting question, let me tell you that. So questions involving three different figures, basically squares, two squares and a circle. So this sort of questions are very frequently asked in exams like GRE and GMAT. So and this is one of the more difficult ones. So we'll take a look at the same and subsequently we'll try and solve the same so that whenever we come across a question such as this, we are easily able to get the gist of it and correctly solve them. Okay. So with that said, let us consider take a look at the question. Two squares lies in a circle having radius 14 root 7. Okay. Find the perimeter of the smaller square. So let me just draw the figure. So here we have a bigger square followed by a smaller square. Okay. So say that this is my figure. Now what we have here is a say circle. Okay, so the circle is something like this, just engulfing both the squares. Okay, so say this is my circle and the radius of the circle up to this point is given as 14 root 2. So therefore the diameter will be 28 root 7. Okay, 28 root 7 will be the diameter of the circle. So therefore we can see, let the side of the bigger square be capital S. Okay, so therefore we can see from Pythagoras we can write 2 alright, S square plus S square is equal to 28 root 7. Okay, we can write this. So 2 S square can be written as 28 root 7, or S square can be written as 14 root 7, or S can be written as okay, so sorry guys, let's start with the Pythagoras part. Sorry, this will be whole square. Okay, so 2s whole square can be written as 28 root 7 whole square. So squaring both sides we can write s, or square rooting both sides we have 28 root 7 by root 2. Okay, so this will be 14 root 2. So therefore s can be written as 14 root 14. Okay, so therefore the bigger sides of the square can be written as 14 root 14. Okay, 14. Now let me do one thing. Let me write this radius down. Okay, this is 28 root 7. Let me join this part from here to here. Let me join this. Okay, and this part let me join. Okay, so we have this particular triangle. Okay, let the side of the smaller square be S. So therefore this particular part will be S by 2. Okay, this length will be basically 14 root 4 by 2 plus S. This will be this line. Okay, and this again will be the radius, or 14 root 7. So here we know this is a right angle triangle with this is hypotenuse. So we can actually write 14 root 7 whole square equal to S square by 4 plus 7 root 14 plus S whole square. Okay, so this would come out to be 14 squared is 196 into 7. Here it is 1 1372 equal to s square by 4 plus 1372 plus 14 root 14s plus s square. Okay, so this is what we have. This and this gets cancelled out, so therefore we can actually write 4s square plus 420 28 56 root 14s plus s square equal to 0, or what we can actually write as, this can be written as 5s square plus 56 root 14s equals to 0. So this one, suppose I further write as 5s square equal to minus 56 root 14s. So if I take square root, let me suppose if I am to write s, and s gets cancelled, so s is 56 root 40 by 5, and I am taking just the absolute value, okay, the smaller side. So this will be option 4 will be our answer. Okay, so I hope this question is clear as to how we came about with the solution of the same. So in case you have any doubt with respect to the approach involved, kindly go through the same. I don't think you should face much of a difficulty. Just go through the entire explanation of how we came about with the solution. Okay. Now, having said that, if you're looking for similar detailed solution of similar sort of questions pertaining to QA, LRDI and BA sections in general, feel free to connect with us and we'll be more than happy to help you out in this regards as well. Okay. So having said that, if you like the video, make sure you like, share and subscribe to the channel so we will keep coming up with relevant content such as this further down the line. So with all that said and done, I'll be signing out. So thank you so much.